Are you able to see this slide? Is anyone?
Yes, sir.
Yes, sir.
I thought of doing at least one problem, okay, related to this. Can you, if you have a pen and paper, can you just note down these problems? We have already finished two, okay, half control and full control converter, okay. I thought that we have seen the turn of time, okay, circuit turn of time and device turn of time, okay. I thought that this is a little bit unique type of problems. All those to find out the output voltage, average voltage, means like RMS voltage, current, power, all these things are there in most of the problems, okay. Yesterday I was just going through the textbook and I feel that this is a little bit unique type of problems there, so I thought we'll solve this problem. A 230 volt 50 hertz one pulse SCR controller. One pulse means is half control, right? So if it is two pulse means is full control converter. So it's one pulse SCR control converter is triggered at a firing angle of 40° and the load current extinguishes at an angle of 210°. So find the circuit turn of time, average output voltage and the average load current for R equals to 5 ohm and L equals to 2 millihenry. Can you just quickly note down this problem so that we'll solve together? Or I think it might take only 1 or 2 minutes. Just quickly note down this problem so that we'll solve together. Or you want to solve it yourself?
We'll
Yes?
solve, sir.
Together, sir.
Tika Benimo, you'll solve yourself.
Sir.
So can you please means note down this problem quickly so that we'll solve. It will not take even 5 minutes also. Okay. Now I think I'll try to connect this to my in my mobile, okay, so that we'll solve here together. Okay. Are you able to see the question as well as are you able to see the question? Is it visible? Questions also?
No, sir. Question not.
No, sir.
Only the screen, mobile screen is visible, right?
Yes, sir.
The question is a 230 volt. Okay, it's a 230 volt 50 hertz one pulse SCR control converter. It's a half control converter. Is triggered at a firing angle of 40°, and a load current extinguishes at an angle of 210°. Find the circuit turn of time. You have to find out the circuit turn of time. Turn of time and average output voltage. So you have to find out VO and circuit turn of TC. So these two things you have to find out: circuit turn of time and average output voltage. Now the parameters given here are R equals to 5 ohm and L is 2 millihenry. So these are the two things given here. Now the circuit turn of time TC is equals to 2 pi minus beta divided by omega. So in this case, so your TC will be 360 minus 210 into pi divided by 180 into 2 pi into 50. So you'll get circuit turn of time around 8.33 millisecond. So this is the circuit turn of time. Now we know that beta is equals to pi minus theta 1. So we can find out that 2 pi, okay, pi minus theta 1, okay, we can find out this is equals to 2 pi. So it will be pi plus theta 1. So beta can be pi plus theta 1. So this is how we solve. So you need to know the circuit turn of time, okay, circuit turn of time and device turn of time. So these two things should be clear to you. So always circuit turn of time will be higher than the device turn of time. So we found out that TC is equal to 2 pi minus beta omega, so you'll get 8.33 millisecond. Now similarly, to find out the VO, output voltage, VO is equals to root 2 to 30 by 2 pi. So it is equals to cos 40 minus cos 250. So with this output, average output voltage will be 84.477 volt. So this is how we'll find out, means average output voltage. And if you want to find out the current, then equals to V naught divided by R. So it will be 84.477 divided by 5. So it will be 16.8954 ampere. So we can find out output voltage. What we have done is we have found out the circuit turn of time. Then we can, this is how we try to find out beta is equals to pi minus theta 1 is equals to 2 pi. So pi plus, so from this, okay, so these two things, circuit turn of time and device turn of, means like device turn of time, these two things are, there are some explanations, okay, if you want in PS Bimra. So please go through this. I forgot the page number, okay, there are, how do you find out the, all these derivation parts are there in PS Bimra. So please go through this and try to solve this problem. Okay, if you have problem, so we'll discuss on this. So this is how you'll get the solution. So today we have already covered these two things, okay, device turn of time and circuit turn of time. And today we'll talk on this dual converter, means half controlled. We have we did half controlled, full control, single phase full control converters. There are different type of full control converters, and now we'll see this dual converters. Now when you talk about dual converters, okay, these converters are used because you get a pure DC at the output. You are using a two converters, that's why the name itself is a dual converters. Two converters are used and you will get a pure DC. There will be no pulsating AC pulsating waves. So two fully controlled converters back to back across the load circuit. So this is how they use two fully controlled converters back to back, and this is either two dual converters. So two dual converter where two diodes are used, so back to back, and this is shown as, so it's used for the high power application. So if you are using a converter in a high power application, then you have to go for the dual converters. And also used for suddenly bringing down the speed of the, suppose if you want to suddenly have a break on the systems, so if you want to have stop systems, then you have to use this type of converter, which is known as the dual converters, and it has this will help to bring down the speed of a drive. And both voltage and currents of either polarities are obtained with the dual converter. So you get either of voltage and current of either polarity with the help of these dual converters. And in full converters, direction of the current cannot be reversed because of the unidirectional. You know that direction of the current cannot be reversed in full converters, and it has, but the polarity of the voltage can be reversed in case of a full converters. And so how do this operate? How do this two converters, dual converters operates actually? So when the alpha, the firing angle is less than 90 degree, it operates in two quadrants, first quadrant and the fourth quadrant. So when it operates, it will, when the theta is, means when alpha is equals to less than 90 degree, then both EDC1 and IGC1 will positive. So this will operate. The one converter will operate when the alpha is less than 90 degree. When the firing angle is less than 90 degree, it will operate in the first quadrant. It means both EGC1 and IGC1 will be positive. Now, when the firing angle alpha is greater than 90 degree, so means means both this will be positive, and when in fourth quadrant, when alpha is greater than 90 degree, then EDC1 it will be positive and IDC1 will be negative. So this is how it operates. When it is less than 90 degree, then it will operate in first quadrant firing, and if it is more than 90 degree, then it will operate in a fourth quadrant. First quadrant power flow from AC source to DC source. So in first quadrant, the power will flow from AC source to DC source, and in fourth quadrant, it will power flow will flow from the DC to AC source. So that's the difference between the operation in the first quadrant and the fourth quadrant. So therefore, we can perform these dual converters in both circulating current and in non-circulating current mode. So this dual converter can be performed in both these cases, in circulating current and non-circulating current. Now
Sir,
this is the basic block diagram of the dual converters where two thyristors are used, and if you see that there's a motor, the speed of the motor can be controlled, or its load can be anything. So this is the ideal cases where the two converters are used. And dual converters are ideal and they produce pure DC output voltage. So yes, I've told you, it will produce a pure DC output voltage, and there is no AC ripple at the DC output terminal. So there will be no DC ripple. If you have seen, if you have remembered, in almost all the half control converter, even if full converter will not get a pure DC. So there are certain AC pulsating waves are there at the output. But in case of a dual converter, you get a pure DC output. And our requirement, we are using the rectifier just to convert AC into DC. So our main requirement is to have a pure DC output. Each two quadrant converters in a like above diagram, we have seen this assumed to be a controllable direct voltage sources connected in series with a diode. So it is connected. There are two diodes used in this, so it's connected to series with the diode. And D1 and D2 represent the unidirectional current flow characteristic. I know the diode is a unidirectional device, and it will represent the unidirectional flow characteristics of the converter. And the current in load circuit can, however, flow in either direction. So in the load circuit, the current can flow in either direction. So it can flow in either in one direction or in another direction. The firing angle of the individual converters of the dual converters are regulated. So you need to know that how the firing is done, because there are two converters used simultaneously. Means that in a dual converters. Now, how does the firing angle, means how does the triggering take place in both the converters? Regulated by the firing angle controlled by control voltage EC. So it depends on the control voltage EC. So the firing angle will depend on this, so that the voltages are equal in magnitude but opposite in polarity. So that your firing angle should be same in both the cases, in both the converters, so that the magnitude will be equal. Voltage, the output voltage, okay, that when you draw a waveform, the output voltage should have a same magnitude, but it can be opposite in polarity. So they can drive the current in opposite direction through the load. So when one converter operates as a rectifier, having given a DC terminal voltage, other converter will operate as an inverter. So it means that the one will flowing from the AC to DC and DC to AC. You have already seen this. In this one, in fourth quadrant, the power flow from DC. In first quadrant, the power will flow from AC source to DC source, and from fourth quadrant, the power will flow from DC to AC. So it means that one converter will act as a rectifier, other will act as a inverter. So when one converter operates as a rectifier having a given DC terminal voltage, and the other converter will operate as an inverter with exactly the same voltage. The one will operate as an inverter, the other will operate as a rectifier in dual converter. So the converter working as a rectifier is called positive group converter. So if it is working as a rectifier, then this is known as a positive group converter. Now, if the converter is working as an inverter, then it is known as a negative group converter. So please remember that if it is working as a rectifier, it is called as a positive group converter. If it is working as an inverter, then it is a negative group converter. So we can find out the average output voltage for both single phase and three phase converters. So EDC will be E max cos alpha, then EDC2 will be E max cos alpha 2. So in ideal dual converters, it's either the circulating mode or non-circulating mode. the average output converters, like average of the converter I is equals to the average of the converter 1. So you can find out EC will be IEDC 1, which is equals to just opposite in polarity. So it will be minus EDC 2. So we can find out the cos alpha 1, which is equals to minus cos alpha 2. So which will be just opposite in polarity, the cos 180 minus alpha 2. You can find out it can be an either polarity, but the voltage will remain same. The magnitude of the voltage will remain same. So alpha 1 will be 180 minus alpha 2. So alpha 1 and alpha 2 should be equals to 180 degree. Now, what is the difference between a circulating current and a non-circulating current mode? So in this mode of operation, only one converter operates at a time. So in non-circulating current mode, it only one converter will operate at a time. You must be thinking, what is the difference of it can operate as both the circulating and non-circulating mode. But in case of a non-circulating mode, only one of converters operate at a time, and second converter will remain in the blocking state. But in circulating current mode, in this mode of one converter operate as a rectifier and other converter will operate as an inverter. It means that both the in circulating current mode, both the converters are working. One will work as a rectifier, other will work as an inverter. But in non-circulating mode, only one converter will operate, other converter will be in blocking state. So please note down this difference. It's quite important to know that what's the difference between a circulating current mode and a non-circulating current mode. Converter may operate in discontinuous current mode in case of a non-circulating, but in case of a circulating current, converter will operate in a continuous current mode. So since no circulating current flows through the converter, efficiency is higher. So in this case of in non-circulating current mode, the efficiency will be higher than the circulating through the converters, and hence increases the losses. Losses will be high in case of a circulating current. So for you to remember this differences between the circulating current mode and non-circulating mode, I know you might have came across this term non-circulating, and you must be thinking that what is the difference between these two? Why do you need to, why the dual converters operate in both the mode, non-circulating and circulating current modes? So this is quite important for you to know this. And one thing you have to know that alpha 1 and alpha 2 should be equals to 180 degree, and the magnitude of the voltage will remain constant, means for the both the converters. But it might means like, so these things are quite important. So dual converter without circulating current. So if this is a case when there is dual converter without a circulating current, so you have two converters. There are 8 thyristors are used in this one, which is connected to the common node. So only one converter will operate at a time, and other converters will provide the entire load current. So if one converter operates, which means it receives its pulse from the thyristor gate control circuit, and the other is blocked from the conductor. So this can be done by removing the gate pulses from the thyristor gate control circuit. So this can be, we can do it by removing the gate pulses from the thyristor gate control circuit. So if you remove the gate, means that once it is start conducting, then which can be blocked. So dual converter with circulating current. This is without circulating current, and this is with circulating current. So what difference can you make out from these two diagrams? This LR1 by 2 and LR, these two are missing in case of a without circulating current. So now I just want to ask you to do this as an, you don't have to submit, okay, but try to find out and write the explanation and the waveform of these two type of converters: dual converter without circulating current and dual converter with circulating current. So your job is now, if I give you everything, okay, I know you'll not work on this, okay, but now you want to, what we have to do is, please try to find out the waveform of this, both for circulating current and non-circulating current, and try to see the operation part also and the basic equations for this. So this is what we have in second unit. So all these dual converters, half control converter, and full converters are what we need to study in second unit, in rectifier, in
Ya kelas 1.
wait, okay, then the dual converter. I think we with this, okay, I'll means what I'm thinking that we'll solve few problems. Is it okay? Or what do you want to do? You want to solve problem yourself or you want to solve together or what is your, because I have there is so many problems, okay. I don't know how many of you are doing this solving these problems. Just wait, okay, I'll connect this. Wait. Okay. Now what I'm thinking is that there is one problem, okay, which is a single phase full bridge rectifier is supplied from 230 volt 50 hertz. Can you able to see this? Do you have a pen and a paper?
Yes, sir.
Yes, sir.
So that means we'll solve one problem, okay, related to single phase full bridge rectifier, okay, and it's supplied from 230 volt 50 hertz source. So of single phase full bridge rectifier is supplied from 230 volt 50 hertz source. So it's 50 hertz, okay. It's supplied from 230 volt 50 hertz source. So this is the source. And the load consists of R. So R is equals to 10 ohm. Okay. And the last inductance so as to render the load current constant. So there is a large inductance. This is so as to render the load current. So this will render the. Can you able to read my handwriting?
Yes, sir.
Okay. Now it's a single phase full bridge rectifier. Okay. This is a full bridge rectifier. Okay. It can be a single phase full bridge rectifier. So this is a full bridge rectifier. Full bridge rectifier. So you have a AC supply and so there is a resistance and the inductance. So you have to find out the output voltage V naught. Okay, average value of output voltage and output current. So you have to find out the V naught, I naught. Okay, from this. So you just have to find out that V naught will be equals to, so V naught will be equals to Vm by pi. So from here you can find out V naught. So I naught will be equals to V naught by R. So this is how you can find out. So average value of the direct current IDA will be average value of means rest, average value of the SCR current. Okay. This can be I naught pi by 2 pi. So with this, okay, you can find out this type of problem. Do you have this PS Bimra soft copy?
No, sir.
Mega.
No, sir.
Actually, I've sent to some of your friends. Okay, if you want, can you just I'll send to your whole of your class in a mail, but I cannot upload in a BLE. Okay, because of the copyright issues. Okay, but today I'll send to all of you. Okay, in your please check your GenEC mail. Okay, I'll send you the copy of PS Bimra. Okay, some of you might be having the hard copy also, PS Bimra and Rashid, but please don't circulate this soft copy. Okay, it's quite sensitive because of the copyright issues. Okay, and I'll ask you to solve this. I'll ask, can you just note down the page number? I'll ask you, okay, please do these problems. Okay, page number 261. This is a textbook. So you today I'll immediately I'll send you the soft copy. Okay, page number 261. Page number 261. Okay. Example 6.5. Example 6.5. 6.4 and 6.5. Both 6.4 and 6.5. Example 260, page number 60 or 61. Example 6.4 and 6.5. These two questions. Other question. Example 6.37. This is in page number 334. 6.37. Even you can try some of the unsolved problem also. There are similar type of problems are there, like 6.21, 6.22, 6.21 and 6.24. So all these unsolved problems also, please try these problems. Okay. So please solve these three problems. Okay. Now 6.4, 6.5, 6.37. So these three problems are, if you solve this, if you are able to solve without looking at the textbook, first just write the questions and try to solve yourself. So if you are able to solve this question, then After solving this, please cross check your answer with the answer in the textbook. So with this, okay, your second unit is over. So Chetan has written, sir, will the AC component like ripple be same when the inverter convert back to AC? Of course, means usually when it converts from DC to AC to DC, there will be some ripple. But these ripples are usually that we try to filter out this ripple so that the only AC component will be remaining back. Now we're converting back to AC. This AC has to be, because on these are the unwanted signal, means that when you convert from like DC to AC, means AC to DC, then this ripple factors will be there. So it will be, means it try to remove those ripple factors, because that is not required. So when you convert back, it will be a pure DC. So that DC, unwanted DC, means the pure DC can be converted back to AC. Now that is inverters in converting back to the as inverting back. So there can be, but there will be some ripple factors, means that when you convert from one form to another form. So even when you convert from DC, means DC to AC, there will be some effect on the, especially when you convert from DC to AC, then you have to take care of the frequency. Where you have to supply frequencies to 250 hertz, so you have to take care of this frequency also. How do you maintain this frequency? So there are certain things you need to, but these inverters, will talk about this in later on, because we have a whole unit on the inverter. But next one will be chopper. So next class we'll do this chopper from tomorrow. I think tomorrow I have same time, 8:30, means 9:30 to 10:30. So we'll do this chopper. So what I'm expecting is that 3 of you, okay, not Abhiskar, but Abhishek, I think 3 of you have not submitted your assignment. I was just going through the assignment yesterday, and some of you have not submitted the assignment. And I didn't get your assignment today also. Means I've given you some, let me see the assignment, those who have not submitted. Wait, okay, there is some problem. I think 3 of you have not submitted your assignment. One is Abhiskar. Okay. Abhiskar has not submitted his assignment. And 3 other.
Sir, I have submitted, sir.
You have submitted?
Yes, sir.
But it's not there in BLE. I could not find in the BLE.
I have submitted first. I have submitted, sir.
But you check yourself, okay, whether it's there in the BLE or not. I could not find in the BLE. I cannot delete it from the BLE also. It's not there in the BLE.
Okay, sir.
Can you please upload again? Means can you upload it? Means this thing means like again in your BLE.
Okay, sir.
The other 2, I forgot the name of 2. Okay, I think it is. I forgot the name. The other 2 of them have even not submitted they have not submitted the assignment. So please check yourself, okay, check your BLE, okay. So only 3 of you have not submitted. So you can check yourself, okay. Last time there was some confusion, okay, with Abhiskar, okay, that he has already submitted the assignment. So while saving the assignment, okay, I saved in a different means number. So please do the other assignment also. I think I have given you enough time to submit this assignment, second assignment also. So please try to solve this thing. And if you have any problem, you can either write to me directly, or we can even discuss next time or whenever you are convenient with this. But I would like to request you, okay, please don't depend on the PPT only, because what I have seen is, this is my experience. Okay, what I've seen is most of you, okay, you just go through the assignment and you just go through the thing, means you go through the PPT only. So these PPTs are just for you to guide only. So once you, okay, please go through the PPT, and at the same time, okay, you have to even like go through the textbooks. Otherwise, it will be quite difficult for you to understand most of the things. In PPT, we might be able to cover only around 50 to 60% only. Remaining, you have to solve for yourself. Just wait. I just want. I'm just taking your attendance. Do you face any problem while solving those problems? Okay, which is, or you have not even tried?
It's direct usage of formula, no? So we are solving something
Yes.
simple.
Most of the problem, because I know there are some problems, okay, which really requires some to analyze something. Okay, I've not given those problems because I know, okay, it's quite difficult to even teach you well, or teaching in the online. Okay, it's difficult to even to convince you. So that's why most of the problems, okay, whatever is there in PPT or whatever I have given you in the last class also, okay, these problems are direct application of formula. And please remember this, most of the students they know how to solve the problem, okay, but because of so many formulas, okay, similar type of formula, starting from the diet, right, half control diet, full control diet, three phase, single phase, then means half wave, okay, full wave, and all this, okay, dual converters. So you'll find most of the formulas are similar, and sometimes few formulas are different for different cases. So please try to look at these formulas, how do you get these formulas, and how to remember these formulas. Most of the time, okay, you get further whether you have to, whether in case of a half control, you use a full control converter. So this you will come across, means you will know only if you solve many problems from the textbook. If you just try to solve one or two problems which is given on the in the PPT or the one which we solve here, this will not really not help you. So please try to solve this. I don't want I don't want to see any one of you failing in this module. And this module is not that tough, because there will be a theory portion around 60%, maybe 30 to 40% will be numerical. So please try to study this theory portion quite well. Means if you have to really get the concept, because when you go to the next semester, means in sixth semester, okay, you have one module which is called as application of power electronics. In application of power electronics, all these power electronic components will be used there for the FACT device, a flexible AC transmission system, static bar components, SBC, static bar compensator, or there are different type of compensators are used in this one. And for that, you need to have a good background of power electronics. It's just application of the power electronics. So all these three power electronics components are used together, and it's known as a flexible AC transmission system. So these things you have to really have a clear concept on this. Those who are studying, I know, okay, there are four of you. Those who are studying in 6 semesters, okay, they are attending in both the classes. I know you must know by now, okay, you must be knowing that this power electronics devices are used in the application part, in fact device, flexible AC transmission system. So please take care of, means try to get a good concept of all this power electronics devices. Okay, so whatever I have asked you to do, please solve this problem. So I'll send you the textbook. Now, if you have some problem, okay, please let me know. Okay. So with this, I'll end here. Tomorrow we'll start with the new chapter, new units, chopper. Okay. Do you have anything to share with me, or do you have any problem? Because we still have some few means like some time. Okay. Okay, then I'll stop here. So we'll continue tomorrow with the new units. Chopper. Okay, bye.